according to Bohr. Then what can we get if we take this Vn then replace it here? So we can get the value of Rn, which is the step number 3. So step 3. Hello everybody. Today's session we continue by our unit, which is atomic model and the photoelectric effect, where the topic is about atomic radius or orbital radius of an electron revolving around the nucleus. Let's solve together the following question. According to Bohr's atomic model, prove whether the orbital radius of an electron Rn at any shell is given by n square h square over 4 pi square ke squared m, where Rn is explained accordingly. Let's explain each symbol, where n is the number of shell or the number of energy levels, and the h is Planck's constant, where Planck's constant h equals to 6.6 times 10 power -34 joule second. K is Coulomb constant by the value listed there. E is elementary charge. M, it is the mass of electron. Pi is mathematical constant, and Rn is the radius of an electron. So let's now go together to see how we can get the position or the radius of an electron at any shell, where is represented by the following equation. So let's go step by step. This question is going to be solved into 3 steps. The step 1, we are going to use Coulomb force and this centripetal force. Remember, we have electron which is revolving around the nucleus. At the nucleus we have proton, and at any shell we have electron. So there must be electrostatic force, which is Coulomb force, which is equal to Ke square over Rn square. It means that this K is constant, of course, as we have seen. This is the elementary charge from proton, even electron. Then this is the Coulomb force we have there. Also, there is a centripetal force, Fc. The centripetal force should be equal to mv square over Rn. Always centripetal force, it is the force that is attract electron toward the center. This force should be equal to the Coulomb force between the two charges. So let's equalize, then see how it is. Ke square, which is equal to this value over Rn squared, equals to mvn squared over Rn. Then in order to cancel this Rn, let's multiply both sides by Rn. Ke square over Rn will cancel with this one, this will cancel with this one, then we remain with Rn, which is equal to Ke squared over mv squared, or Ke squared over Rn would be equal to mvn squared. This is named as equation number 3. Remember, equation number 1 is the Coulomb force between the two charges. Question number 2, it's about centripetal force. By equalizing, we get the following result, where Ke squared equals to mvn squared. It is named as equation number 3. So now step 3, it's about angular momentum. So from Bohr's theory, or from Bohr's postulate, the angular momentum of electron, angular momentum refers to the product of mass times the velocity times the radius at which electron is revolving. So remember, the linear momentum equals to the mass times the velocity of the body. But here, because electron is revolving at n shell, so we must multiply the radius at which electron is positioned because it affects this angular momentum. So from Bohr's postulate, angular momentum will be equal to the mass of electron times the velocity of electron at that shell, even times the radius of electron at that shell, which is equal to n h square over 2 pi. Then we will solve the value of Vn. It means that mv n and n equals to nh over 2 pi. Then mvn and n equals this value. Then you find the value of Vn. This is the value of n you want to find. nh over, which this one over 2 pi, this one over m and n. This we have here. So let's call it equation number 4. Then step 1, remember, we equalized a centripetal force and the Coulomb force. Then you find the value of this equation K. This is the relationship between these two equations, Coulomb force and the centripetal force. So by now, let's find for V according to Bohr. Then what can we get if we take this Vn, then replace it here? So we can get the value of Rn, which is the step number 3. So step 3 is just to substitute equation 4 into equation number 3. Remember that equation number 3 was equals to Ke squared over Rn, which is equals to mVn squared. Then let us substitute the value of Vn from equation number 4. From equation number 4, which is this one, equation number 4, Vn, then we are going to replace or to substitute this Vn into the equation. Let's go. Now, Ke squared over Rn, which would be equals to m, this one, here, Ke squared over Rn, which is this one. Let's take this value of n, replace it there. Then we will get m, replace this value of n, then we square on both sides as it is given from equation number 3. Then we will get Ke squared over Rn, which is equal to this mass m times n squared h squared over 4 pi squared m squared Rn squared, which is this value. So now we will cancel with Rn, will be cancelled with this square, then mass per mass square. Then finally we will get Ke square 4 pi square mRn, which is equal to n square h square. Thus finally we will get the value of Rn, which is equal to n square h square over 4 pi squared Ke squared times m, which was the one which was finding out. So these are the steps we are going to use. Then we have used, then we find the value of Rn. So let's take homework. Next we shall prove whether Rn equals to n square Rn. Can you try, please? Try. I wish you the best. Thank you so much.